Good morning. Today's podcast is Offshore Wind Turbines Electrical Equipment, Clean Energy Transition Powerhouse, read by Ryan Smith from Rotex Technologies. The offshore wind energy sector has emerged as a crucial player in the global push towards renewable energy sources and the fight against climate change. With its ability to harness strong, consistent winds found over open water, offshore wind power is becoming increasingly important in the world's energy mix. Offshore wind market size and growth. The offshore wind market has experienced remarkable growth in recent years. As of 2024, the global offshore wind capacity stands at approximately 65 gigawatts, with projections indicating a surge to over 250 gigawatts by 2030. The market is now dominated by Europe, which accounts for over 50% of global offshore wind capacity. However, China is rapidly expanding its offshore wind sector in exceeding the market share by Europe in next couple of years. The total installed capacity of offshore wind turbines in operation in China amounted to around 31.5 gigawatts at the end of 2023, with additional 6.3 gigawatts of offshore power under construction, overtook the United Kingdom as the world's biggest offshore wind market in 2021. The UK is second leading country in offshore wind, accounting for about 20% of global offshore wind capacity. In 2024, the UK has 13.9 gigawatts of fully commissioned offshore wind capacity, with projections to reach 19.5 gigawatts by the mid-2020s. Germany comes in third place with 8.3 gigawatts in operation and 1.6 gigawatts under construction by 2023. This exponential growth is driven by several factors: declining costs due to technological advancements and growing economies of scale, governmental support as part of their climate change mitigation strategies, improved technology with larger, more efficient turbines and innovative foundation designs, and increasing corporate commitments to renewable energy at a foreseeable robust market demand. Electrical equipment for offshore wind turbines. The electrical equipment and system are the heart of the wind turbines, converting kinetic energy into electricity. The key equipment are generators. The most common type of generator used in offshore wind turbines is the doubly fed induction generator DFIG, and permanent magnet synchronous generators PMSGs. DFIGs have the advantage of variable speed operation, and can control the active and reactive power independently to some extent. PMSGs, on the other hand, have higher efficiency and better power quality output. Motors. There are usually three-phase induction motors used for various auxiliary systems such as yaw motors and pitch motors. The yaw motors are responsible for rotating the nacelle of the wind turbine to face the wind direction. The pitch motors control the angle of the turbine blades. Despite the induction motors are reliable, there is a trend to introduce permanent magnet motors at IE4 or IE5 class to improve power efficiency further. Power converters. These are essential components that convert the variable frequency, variable voltage output of the generator to a fixed frequency and voltage suitable for grid connection. They play a crucial role in power quality control and grid-friendly operation of the wind turbine. The power converters usually consist of insulated gate bipolar transistors IGBTs based switching circuits and associated control systems. Transformers. The transformers are used to increase the voltage of the generated electricity to a level suitable for transmission to the onshore grid. These transformers are usually located in the nacelle or at the base of the turbine tower. They need to be designed to withstand the mechanical vibrations and corrosive offshore environment. Switchgear and circuit breakers. They are used for protecting the electrical system from faults such as short circuits and overcurrents. The switchgear allows for the safe isolation and connection of different parts of the electrical circuit, and the circuit breakers can quickly interrupt the current flow in case of a fault to prevent damage to the equipment. There are auxiliary equipment such like substation, control systems, and power cables to maintain the stable supply of electricity transmitting to the onshore substations. Challenges for electrical equipment in offshore wind turbines. Due to exposure to salty atmosphere and humidity accelerates corrosion, the electrical equipment must be designed for protection against these harsh environment. In addition, the extreme weather conditions, such like lightning strikes, pose a significant risk to the electrical systems. The proper insulation in humid environments needs to maintain, with effective grounding systems for safety and lightning protection. Most of the electric equipment are installed in turbine nacelles with limited space because of size, cost, and weight constraints for turbine design. The proper cooling has to be considered for electrical components in confined spaces, preventing equipment overheating, particularly for generators and transformers. To improve the power quality, it requires to maintaining stable power output under variable wind conditions, and managing voltage and frequency fluctuations. It also requires to minimize electromagnetic interference, to prevent disruption of control systems and communication equipment. The design life for wind turbine operation is a typical 20 to 25 years in harsh conditions. The equipment must operate continuously for extended periods with minimal maintenance. The offshore wind farms are built remotely with difficulty of access for maintenance and repairs. It requires a robust equipment design and maintenance plan for long-term reliable operation with cost considerations. These challenges require specialized design, materials, and maintenance strategies to ensure the reliable and efficient operation of electrical equipment in offshore wind turbines. Ongoing research and development in this field aim to address these issues and improve the overall performance and longevity of offshore wind installations. Technology trends of electrical equipment for offshore wind turbines. The future trends in the development of electrical equipment for offshore wind turbines are as follows. Higher power ratings and efficiency. Increased turbine capacity. Offshore wind turbines are continuously increasing in size and power output. Electrical equipment will need to be designed to handle higher power ratings, with generators, transformers, and power converters being developed to support turbines with capacities of 18 megawatts or even higher in the near future. In a recent report, Dongfang Electric will install a 26 megawatts offshore wind turbine, which is certainly a game changer. Improved efficiency. There is a continuous focus on improving the efficiency of electrical components to maximize energy conversion and reduce losses. For example, advanced power converter technologies with better control algorithms and semiconductor devices will be used to optimize the generator's operation and increase the overall efficiency of the wind turbine system. Advanced materials and designs. Superconducting materials. The use of superconducting materials in generators and other electrical equipment is a potential trend. The superconducting generators can offer higher efficiency, reduced size, and weight compared to their traditional counterparts. Improved efficiency. There is a continuous focus on improving the efficiency of electrical components to maximize energy conversion and reduce losses. For example, advanced power converter technologies with better control algorithms and semiconductor devices will be used to optimize the generator's operation and increase the overall efficiency of the wind turbine system. Lightweight and durable materials. To address the challenges of offshore installations, such as the need for lighter components to reduce installation costs and the requirement for durability in harsh environments, the development of new lightweight and durable materials for electrical equipment is expected. Improved reliability and durability. Corrosion resistance. Given the harsh offshore environment with high salinity and moisture, electrical equipment will need to have enhanced corrosion resistance. This may involve the use of special coatings, materials, and sealing techniques to protect components from corrosion and extend their service life. Robust design and testing. Stringent testing and validation procedures will be employed to ensure the reliability and durability of electrical equipment. This includes testing under extreme conditions such as high winds, waves, and temperature variations to simulate the actual operating environment of offshore wind turbines. Sany unveiled their 35 megawatts offshore wind turbine test bench, which is able to accelerate the turbine fatigue test and accommodate even more larger wind turbine design and testing. Enhanced grid integration and smart technologies. Advanced grid connection capabilities. As the share of offshore wind energy in the power grid increases, electrical equipment will need to have better grid connection capabilities. This includes the development of more advanced power converters and control systems that can ensure stable and reliable power supply to the grid, handle grid disturbances, and provide reactive power support. Digitalization and smart monitoring. The integration of digital technologies such as the Internet of Things (IoT), artificial intelligence (AI), and big data analytics will become more widespread in offshore wind turbine electrical equipment. Smart sensors and monitoring systems will be used to collect real-time data on the performance and health of electrical components, enabling predictive maintenance, optimizing operation, and improving the reliability of the entire wind turbine system. Standards and best practices for electrical equipment. The offshore wind energy industry has some important standards and best practices widely accepted by the offshore wind energy industry for electrical equipment installation. Standards. International standards. Bodies like the IEC and ISO have developed a range of standards. For example, the IEC 61400 series provides guidelines for the design, installation, and operation of wind turbines, covering aspects such as load calculations, safety requirements, and electrical systems. Regional and industry standards. For example, the standards are developed by the European Committee for Standardization Centre, the British Standards Institute BSI in the UK, and the China National Standard GBT for maintain the safety of the electric equipment for wind turbine sector. Some organizations have developed standards that are relevant to their respective industry or region, standardizing the electrical equipment in installation and operation in offshore wind turbines, for example, API, DNVGL, NORSOC, etc. Best practices. Offshore wind farm development involves careful project planning and site selection. Construction and installation require stringent quality control measures and efficient logistics management. Operation and maintenance best practices include predictive maintenance using condition monitoring systems and data analytics, as well as investing in workforce training. These practices aim to minimize environmental impact, ensure economic viability, reduce downtime, extend equipment lifespan, and gain community support, ultimately contributing to the successful implementation and operation of offshore wind projects. As the world continues its transition towards renewable energy sources, the offshore wind energy sector is set to be a key player in the pursuit of a sustainable energy future. The rapid growth and technological advancements in the offshore wind sector underscore its potential to be a cornerstone of the global energy transition. As costs continue to fall and new technologies emerge, offshore wind is likely to become an increasingly attractive option for countries and corporations looking to decarbonize their energy systems. In the path to net zero carbon emission, it's an exciting time for electrical equipment manufacturers, installers, and operators in continuation of improving design, technology and innovation for global expansion in offshore wind sector. Thanks for listening. Please visit www.rotextechnologies.com to learn more. See you next time.